will see matrices and determinants today. We will start with the basics of matrices. Here is the matrix is defined as the arrangement of elements or items in rows and columns, that is in two-dimensional array. For example, if we say A is a matrix and I can arrange the elements in rows like A11, A12, A13, etc. up to A1n, and this is going to be the first row, and the second row is going to be A21, A22, A23, like that. I can extend up to A2n. Similarly, the third row and fourth row can be written the same way, and I am just writing the nth row. So AM1, AM2, like that. I can just written up to this AM. So what do you infer from this? Say I have denoted the numbers 1, 1, 1, 2, 1, 3. What it means? This 1, 1 represents the first number, represents the row. The second number represents the column. So this A11, it is said to be kept in the first row, first column. So what do you mean by the first row, first column? So this is what the first row, and this is first column. And here, when you take this A12, it presents in the first row and the second column. Suppose you take this A22, so where the position of this A22 is? It is in the second row and second column. Similarly, this AMN will denote the representation of these elements in the mth row and the nth row. So generally, we define or we say the order or the size of the matrix A as m by n. So that means that this matrix is said to have m rows and n columns. Okay. So when this m is not equal to n, then we can say this A is a rectangular matrix. Why it is said to be a rectangular matrix? Because the number of rows and the number of columns are different. Okay. And if this m is equal to n, then we can say A is a square matrix. So what do you mean by this square matrix? Here the number of rows and the number of columns are equal. For example, say for for a rectangular matrix, I am just taking 1, 2, 3, 4, 5, 6. So if you take this matrix, the number of rows are 2 and the number of columns are 3. So this is row 1, row 2, this is column 1, column 2, and then column 3. So here this 2 by 3, the 2 and 3 are not equal, so it is said to be a rectangular matrix. And also we can say 1, 2, 3 or 4, 5, 6. Here though we have only two columns and 3 rows, here the number of rows and the number of columns are different. So they are rectangular matrices. But if you take a square matrix, the number of rows and number of columns would be same. So for example, if you take say B as a matrix, I am just writing 1, 2, 3, 4. So here we have 2 rows and 2 columns. Okay, so the number of rows and number of columns are equal, so it is said to be a square matrix. So we can name this matrix as a 2 by 2 matrix. Similarly, we can also have a 3 by 3 matrix. See 1, 2, 3, 4, 5, 6, 7, 8, 9. And just for example, I am giving these numbers. Okay, so here we have 3 rows and we have 3 columns. So it is said to be a square matrix. So now you have understood how we can arrange, because in most of the scientific and technical applications, we require the representation of the numbers in two-dimensional array, that is in the rows and the columns. Okay, thank you.